Regression analysis is essentially a statistical process for assessing how two or more variables relate to one another. In ordinary least squares regression, it often focuses on the potential linear associations between a dependent variable or the outcome variable and one or more independent variables, or we sometimes call them predictors. In other words, in ordinary least squares regression or in the OLS regression, the relationship between the dependent and independent variables can be approximated by a straight line. We can also say that a straight line provides a good linear relationship between the independent and the dependent variables. We build regression models for inference purposes and for predictive purposes. The inference and predictive purposes are normally done through different forms of regression analysis. And these different types of regression analysis can be the ordinary least squares regression or the OLS regression, the logistic regression, the autoregressive models we see in econometrics, spatial regression, some types of non-linear regression, polynomial regression, and so on and so forth. Before we start fitting regression models, we begin the model building process by performing something we call an exploratory data analysis or EDA. One way to perform an exploratory data analysis or EDA would be to add a scatter plot of dependent variable versus one or more of the independent variables. These will help us determine whether the nature of the relationship between the dependent variable and the independent variable is linear. A scatter plot of dependent variable versus one or more independent variables is also called the scatter plot matrix. As you can see from the figure below, it seems that there is a negative relationship between the independent variable or x and the dependent variable or y. The relationship looks linear here. Thus, it is possible to fit a straight line to the data using the least square method or the ordinary least square regression method. And fitting the straight line to the data will also lead to the smallest possible sum of squared error. And we will talk about what we mean by the sum of squared error in later slides. As you can see from the scatter plot matrix below, there is a positive relationship between y and x3, between y and x4, and a negative relationship between y and x8. The scatter plot matrix indicates that the linear model fits the data well, and therefore the linear regression model can be used for prediction in this case. Regression is an approach for modeling the regression. In this case, There can be numerous factors that can determine the predicted number of COVID-19 cases in a given city, in a given state, in a given country, depending on the unit of analysis. The unit of analysis can either be city, town, county, state, or even zip code. Depends on what's available. I mean, what data is available from the government or other legit sources. So, in this case, the percentages of adults with diabetes, the percentages of adults who are obese, the percentages of adults who are smokers, the percentages of adults who identify themselves as heavy or binge drinkers, the percentages of adults without health insurance. When we talk about adult population, we sometimes means those 18 and over or those 20 and over. Some surveys, they measure percentages of adults with a certain characteristics as those 18 and over, and some use age 20 as the cutoff points. And the predicted number of COVID-19 cases can also be influenced by the ratio of population to physicians, the ratio of population to mental health providers, the extent of income inequality. And this is often measured by the ratio of those in the 80th income percentile to those in the 20th income percentile. And the predicted number of COVID-19 cases can also depend on the percentages of overcrowded household in a given city, in a given state, in a given county. The predicted number of coronavirus cases can also be determined by the median household income in a given city, in a given state, in a given town, in a given zip code, in a given country, and so on and so forth. The predicted confirmed COVID-19 cases can also depend on the percentages of population aged 17 or younger. The predicted number of COVID-19 cases can also depend on the percentages of population who are 65 and older, or we sometimes call them the elderly population. And the predicted number of COVID-19 cases can also be influenced by the total population in a city, in a town, in a state, in a zip code, in a country, and so on and so forth. The number of COVID-19 cases can also depend on the percentage of population who are black or who are Asians, who are other racial ethnic groups in a given place. The number of COVID-19 cases can also depend on the percentage of population living in rural areas in a given city, in a given state, in a given zip code, in a given country, and so on and so forth. And the expected or predicted number of COVID-19 cases can also depend on other more relevant or more reliable measures pertaining to an area's susceptibility or resilience to this pneumonia of unknown source. And sometimes these factors are not available in government data in other legitimate data sources. So, this is one example where ordinary least square regression can be used, because there is a linear relationship between these independent variables and the dependent variable. In this case, all these items listed by bullet points would be the independent variables, and the expected number of confirmed COVID-19 cases would be the dependent variable. In regression analysis, our goal is to find out how E is the error or disturbance term. In regression analysis, our goal is to find out